Alright, moving on with the graph of a times sine of n brackets x minus h, and we can do the same with cos. We earlier looked at the graph of a sine or cos nx. What I'm gonna refresh your memory about the a and n. So a here will, it's a dilation of factor a. Let's assume a is positive, so it's a factor a from the x-axis, and it will affect the range of the function. With the n here, pay attention also to the brackets. So n here will indicate it's a dilation of factor 1 over n, so the reciprocal, and it's from the y-axis. What it also does is affect the period of the function, and the period, I annotate t, capital T is the period, is defined as 2 pi over the n value. Okay, if you have inside the bracket a minus h, it's a translation of h units in the positive direction of the x-axis from that function you start with, from a sine of n times x. Okay, so let's do an example with sine n cos. Remember, cos is just a translation of sine as well. You can use a calculator to help you with the shape, but those things you should be able to do by hand. You have a restricted domain here, okay, but you should not worry too much about it yet. You need to start with the graphing of that. So the first one is you're going to focus on the 3 and the 2 here. So the 3 value here will tell you the range, so you're going to go all the way to positive 3, and the minimum will be negative 3. The 2 here, you do 2 pi divided by 2, that gives you pi, so the period is pi. Okay, using the starting value of pi on 4, when you substitute that, that gives you pi on 4 minus pi on 4 is 0. Sine of 0 is actually 0, so you start at 0 here. If you add pi, you actually end up to the upper boundary. So your starting point is at 0, and you're going to finish at 0. So you start at 0 and you finish at 0. You get a full cycle across. So what you do is you do one wave, you cross the right in the middle the x-axis or the t-axis again, and as you go upwards in between, so at pi on 2 you get a maximum, and at pi you get your minimum of negative 3. Okay, next one, you have 2 and 3, so the value 2 gives you the range, the 3 gives you a weird period of 2 pi on 3. Again, with that starting value, it makes this 0, and cos of 0 is 1. So because cos of 0 is 1, you multiply by 2, you will start at 2. Okay, if we add 2 pi on 3, we get the end of the domain. So over the domain we get a full period. So from, as you go a full period, you go a wave, so that's your maximum, so you have to go down, you go to the minimum, and you go all the way back up to the same maximum value at pi on 3. Look for the middle value. Due to the symmetry negative pi on 3 and pi on 3, the middle value is 0, so at 0 you get your minimum of negative 2. And then in between negative pi on 3 and 0, or 0 and pi on 3, which is pi on 6 and negative pi on 6, you get your x-intercepts. Okay, all right, so this is the approach how to graph it. So you look at your two dilation factors, Then you look at your translation. You can use the starting value to find where the 0 is, because sine of 0 and cos of 0 are exact values that you should know. Now the next method is by using the mapping of coordinates. So you should know how to graph y equals sine of t. And let's say you had that following transformation from the previous example. So that's your original function, and that's your transform function. Okay, the transform function relates to the y prime, t prime, or x prime that we used before. You're going to take this equation and you're going to rearrange it to make sine on one side the subject. So we transpose the 3. So the right hand side, sine of whatever we have here, looks very similar to that. And the left hand side, we're going to match it to y. So by matching the left hand side, y to y prime over 3, we're going to get this one. Okay, and the right hand side, we're going to map the sine of t with the sine of 2 brackets t prime minus pi over 4, and we make it equal. Okay, so those two are your mapping equations. You rearrange them again to make y prime and t prime the subject, and then from that what you can just do is actually list the transformations. So the 3 here gives you the dilation of factor 3 from the t-axis. The 1 over 2 in front of t, or the x-axis, is a dilation of factor 1 over 2 from the y-axis. And the plus pi on 4 here is a translation of pi on 4 units in the positive direction of the t-axis. So notice it's in the positive direction, but you started with a minus here. But by doing the mapping, it gets transposed to the opposite, and that shows you that it's to the right. Okay, and the alternate method is what we done in the example, is by doing a sequence. We observe the graph and follow the different transformations, and you can do that by isolating your function f of t, which is your sine, and then by doing the coordinate mapping, you're gonna get the transformations in that sequence. So with that last one, the alternative, sorry, it's not linked to the example, it's actually just a rewriting for a general function. So we're gonna call f to be our sine, and you will be able to do that with cos as well. And we have our original f of t, and we have the transform over there by substituting sine by f, and that follows the same sequence. Alright, that's it for this exercise, and I'll see you in the next video.